All right, here we have section 1, topic 10. It's an introduction to coordinate geometry. So coordinate geometry, that's what goes in these spaces here. Coordinate geometry involves placing geometric figures like triangles and rectangles and parallelograms and lines and segments in a coordinate plane. And remember, the coordinate plane is this. So we have coordinates, we put our figure in here. This is what they're talking about, okay? It's a very specific way for us to look at lengths and slopes of lines and things like that. All right, so far in this course, we've used coordinates in the following ways. So we've done the midpoint formula. So just to remind you, that was to take a segment and find the middle point. So the description is it gets us the middle of a segment. And in order to find that middle point, we can use this formula that says if you take the average of the first and second x coordinates and you take the average of the first and second y coordinates, you'll find the middle of both of them. You'll find the middle of the x's, the middle of the y's. That will be the middle of the segment. All right, the distance formula, if you remember, is basically just the Pythagorean theorem. Truly, it is just the Pythagorean theorem rearranged. And by rearranging it, we see the square root of the difference of the x's squared. That gives us the distance of the x side added to the difference of the y side. So, the difference of the y coordinates squared. So this is like a squared plus b squared equals c squared. And then to get c by itself, we take the square root of the whole thing. So one leg squared plus the other leg squared, square root of the whole thing. This is just the Pythagorean theorem. Rearranged. And it helps us find the length of a segment. All right, and then we have the slope formula. And the slope formula is just the difference of the y's, that's the rise, over the difference in the x's, that's the run. We say rise over run. So when we have it on a picture, it's a whole lot easier to do. There you go. And this is to give us the steepness of a line. Or the steepness of a segment on a graph. And if the line is going uphill, that's a positive slope. And if it's going downhill, that's a negative slope. And we always read those going left to right, left to right. All right, so let's practice. Given A, D, and H, plot the points and trace the triangle. All right, so we're going to go ahead and plot these points on here. So we have, oops, there's 0, 0. Sometimes it's hard to see on these graphs. All right, 1, 2, 3, 4, -4, +8. 1, 2, 3, 4, 5, 6, 7, 8. There it is. This is point A. Point D is at -7, +4. And point H is at -3, +1. There we go. Plot the points and trace the triangle. All right, so we want to use a nice straight edge for our sides. There we go. All right. What is the perimeter of that triangle? All right, so unfortunately, none of our sides here are a nice horizontal or vertical length that we can just count. So we're going to have to use the distance formula right here. So remember, it's the Pythagorean theorem. And that is this formula here, the difference in the x coordinates squared plus the difference in the y coordinates squared to give us those two leg lengths, and then the square root of the whole thing. So if you recall, we can just use the distance formula, or we can use Pythagorean theorem. So on the first one here, AH for the distance, I'm going to use the formula, and then we're going to use, we're going to draw pictures of our triangles to use Pythagorean theorem the second time. But just for AH, we're going to look at these 2 points right here and plug them into the formula. So here we go. The square root of, all right, let's look at our x coordinates right here. And we'll do -3 minus -4 squared added to the y coordinates, 1 minus 8 squared. So this is -3 plus 4 squared, and that's that -7 squared. This one is 1 squared plus -7 squared. All right, so let's do that. 1 squared is 1, plus 7 squared is 49. So this is the square root of 50. And we are, at the end, going to be rounding to the nearest hundredth. So I'm going to leave it as the square root of 50 for now, but we'll come back to it. All right, so that's the side, the distance of AH. So we still need AD and DH. All right, so I said we were going to draw the rest of the triangles so that we could use Pythagorean theorem. So for this distance right here, we're going to draw the vertical and horizontal lines to create this nice right triangle right here so that we can use Pythagorean's theorem. This side length is 3, and this side length is 4, and so we do, the distance of AD here is 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. That's 25 equals c squared. Remember, you take the square root at the end, and the square root of 25 is 5. So this length right here is 5. So let's go over here. The length of AD is 5. All right, so we have 2 of our side lengths. We need 1 more. Here we go. Draw your triangle. This side length is 3, this side length is 4, and notice this one is exactly identical to this triangle over here, so I know that side length is 5. So the side length for DH is 5. Add all those together to get the perimeter, because perimeter is add up all the sides, and we get 10 plus the square root of 50, which we'll now go over to our calculator and do. The square root of 50 is about 7.07 if we're rounding to the nearest hundredth. So 10 plus 7.07 is 17.07 about for the perimeter. There you go. All right. Prove that the measure of angle ADH is 90 degrees using the slopes of AD and DH. All right, so let's look at segment AD. The slope of segment AD, and we need to look at the slope of segment DH. All right, so the slope of segment AD right here is, and we're going to go ahead and use the rise and run that we have marked here for AD. It's rise 4, run 3. Rise 4, run 3. And for DH, it's, remember I said start on the left point always, it's drop 3, run 4. Drop 3, run 4. Okay, so what do we know about these slopes? They're the opposite, positive, negative, and the reciprocal, the flip. So the opposite reciprocal, that gives us perpendicular slopes, or perpendicular lines. And perpendicular is 90 degrees. So, yes, AD and DH form 90 degrees for the measure of angle ADH, which is right there, ADH. That makes a perpendicular line, perpendicular lines right there. So, all right, we're skipping part C, that's fine. And we're moving on to, we're skipping this one, and we're going on to this try it right here. Charisse is planting a vegetable garden in the shape of a triangle. She plans to plant tomatoes on the left side and peppers on the right side of the partition. This is a partition right here that is perpendicular to ON. So this nice right angle here. If she has 35 feet of fencing, does she have enough to fence in the entire garden, all the way around, and add the partition? So she wants fencing right here between her tomatoes and peppers. Round your answer to the nearest hundredth. All right, she has 35 feet of fencing. So the horizontal and vertical sections here are really easy to count. So this starts at 2 and goes all the way over to 12, which means that this has a length of 10 feet, all the way from this end to this end. All right, that's one side. And then the partition right here starts at 1 and goes up all the way to 9. So this has a length of 8. So we also have 8 feet. So now we just need these two sides right here. And again, we can use the distance formula, or you can use it in the form of Pythagorean theorem by looking at your leg lengths. And we already can tell what 2 of these leg lengths are. This one is 8. And let's look at this. This goes from 2 to 6, so that's 4. So if you have a leg length of 4 and a leg length of 8, put that into Pythagorean theorem to figure out what MO is. All right, so the distance of MO is 4 squared plus 8 squared, and you got to take the square root of that at the end. So that is the square root of 16 plus 64, which is the square root of 80. All right, I'm going to go ahead and just put that over there. We'll take care of rounding here in a minute. All right, let's go do the other leg. So if this is 4, let's see, this goes from 6 to 12. This is 6, and that's 8. So we have a 6 side and an 8 side, and we're going to do this again. The distance of MN is, oh, I'm going to run out of white space here. 6 squared plus 8 squared. I don't think you can read that. I'm going to do that somewhere else here. Let's do this over here. The distance of MN is the square root of 6 squared plus 8 squared. That's 36 plus 64. That is 100. And the square root of 100 is a nice, beautiful 10. So we'll just add 10 onto our total perimeter here. So we have 10 plus 8 plus 10, so 28, plus whatever the square root of 80 is. So we're going to go over to the calculator, and we'll do the square root of 80, which is about 8.94, and add that to the 28 that we have here, and we get 36.94. She has 35 feet of fencing, so does she have enough? The answer is no. There you go. All right, we're moving on to the next page. This is the last thing that we're doing in this lesson here. Jerome and Eric start their hike at point A and follow the trail in the counterclockwise direction. Okay, remember, clock goes this way, so they're going this way. So they're starting here, and they're traveling that direction all the way around. They stop at point W to eat lunch, so they're going to stop over here. How many total miles have Jerome and Eric hiked when they stopped for lunch? Round to the nearest tenth of a mile. All right, so let's look at the easiest ones first. And the easiest ones are if you have horizontal or vertical distances. This one's really simple here. Count that, that's 2. And this one here, that's 2. All right, and then we're gonna attack this one first. So to get that distance, we're gonna use Pythagorean's theorem and look at these leg lengths. This is 2, this is 2, right? So this one right here, the length is 2 squared plus 2 squared, and then take the square root of it. The square root of 4 plus 4, the square root of 8. All right, so we're gonna write, that's the square root of 8. We could simplify that, we could put it in simplest radical form. For now, we're just gonna leave it as the square root of 8. All right, look at this length right here. This also has a 2 and a 2 for its 2 leg lengths. So since we've already done one of these, we already know this is the square root of 8. All right, look at this one. This one also has leg lengths of 2 and 2, so this one has a length of the square root of 8. All right, so now all we have to do is add up all these pieces. This with this, with this, this, and this. All right, so we have 2 plus 2 plus the square root of 8 plus the square root of 8 plus the square root of 8. Repeat addition is just multiplication. This is easy right here, 4. And we can write here that this is 3 times the square root of 8, or 3 of them. And then we'll come over here to our calculator and do the square root of 8. That's this. Times 3 of them, that's this. Add 4, that's this. There you go. And it says round to the nearest tenth. So we're at 12 and a half, 12.5. All right, there you go. That's it.